So let's answer these 5 questions from this piecewise function. If I want to find f of negative 2, that means I want the value at negative 2. What you notice for this piecewise is negative 2 is where these two graphs might connect. It's where the intervals switch. So basically, for f of negative 2, I have to look at which interval has negative 2. That means it's this one, because it's greater than or equal to negative 2. So that means I'm going to plug negative 2 in right to this equation. So that's going to be 2 minus negative 2 over negative 2, which is 4 over negative 2, which is negative 2. So that is the value at negative 2. Next, I want to know the limit as x approaches negative 2 from the negative side, which is the left side. So which of these intervals is from the left side of negative 2? It's that one. Left side means less than negative 2. So I'm going to use this function to find the value coming from the left at negative 2. So I'm going to do 3 times negative 2 minus 5, which is negative 6 minus 5, which is negative 11. So that is what the graph is coming to. This line is coming to negative 11 at negative 2. This is not a coordinate because it's the coordinate's down on this one. Now, if we're coming from the positive side of negative 2, that would be this interval. So what are you approaching? Well, what you're going to do now is put negative 2 into this, which you did right here. So that answer, since we did it already, is negative 2. All right. So the value is negative 2 at negative 2. From the left, it's negative 11. From the right, it's negative 2. So these two limits do not agree. They don't go to the same point. So what is the limit at negative 2? It does not exist. The reason it does not exist is because the limit from each side is not the same. And that's the definition of a limit, is that the limits from both sides should be going towards the same point. So we know there is no limit at negative 2. So where is f of x discontinuous? Well, first thing we check is each at the breakpoint, because we want to see if these are connected. And what we noticed here is they're not. They do not touch. There is no limit at negative 2. They don't approach the same spot. So there is a discontinuity at negative 2. They do not meet. So my first discontinuity is going to be at x equals, let me change that, at x equals negative 2. Now, let's think of any other discontinuity. For instance, this is a line. A line is continuous. It never has an error or an issue, so we don't have to worry about this one, but this one has an error. Because if I plug in 0 into this denominator, I'd get a undefined. And if I think about it, is 0 in this interval? Is 0 greater than or equal to negative 2? And yes, it is. So this error, this discontinuity right here, is in that interval, so I have to include 0 in my discontinuities because 0 would make an error to this particular function. So I also have 0. So my two discontinuities are negative 2 and 0. At negative 2, it's a non-removable discontinuity, and so is 0. All right, because if you know anything, this right here would be an asymptote, and at negative 2, they come from both sides and don't come to the same